Okay, we're going to start out by changing this standard quadratic equation into vertex form. And we'll start off with the methods we've used the last few days. I like to go ahead and get rid of this f of x, and I'm going to do the work down here in this purple box. And let's go ahead and grab a pen here. I'll use a light color so it shows up on the purple. I'm going to go ahead and set this equal to 0. So let's do this equals 0. And now I'll go ahead and move that positive 7 to the right side. And I'm left with this. All right, on the left I have a binomial. I'm going to turn that into a trinomial. You'll notice I left this little space right here. But I also don't like this 4 here. So conveniently, this 4 goes into both terms. So I'm going to go ahead and pull a 4 out of both those terms. And we have this. You'll notice I expanded it out into a trinomial. What goes in this spot will always be b divided by a, or excuse me, b divided by 2. And in this scenario, my b is 2, and 2 divided by 2 is 1. Okay, I'm going to go ahead and clean it up a little bit. And we're to this point. Now, since I did just add, I'll scroll up here, this 1 here, okay? The rule is I don't get to just magically add that 1 on that side of the equation without doing it on both sides of the equation. So I need to go ahead and put that 1 over here. But I also have to remember it's not just a 1, it's 4 times 1. So I'll say plus 4 times 1. And then on the left side, I'm going to go ahead and factor, and I'll clean up the right side. And we're left with this. And now I have 2 binomials that factor the way that I want them to look. And then the last step, I'll go ahead and move this 3 to the other side. And I'll go ahead and write my final answer here. And this is a vertex form of this standard quadratic function. And so I'm going to go ahead and write that up above, and then I can get rid of this work, and we'll reveal what's underneath the purple screen. So up here, I'm going to say this is equivalent to f of x equals 4 times x plus 1 quantity squared plus 3. And then we'll go ahead and get rid of all this work. All right, we'll go ahead and reveal the screen and get started on example 1. And example 1 is we are going to analyze this function. So we're going to do the domain, range, continuity. Is it increasing or decreasing? Symmetry, boundedness, extrema, and horizontal and vertical asymptotes. We'll start out. We know how to graph this thing. We know the vertex of this particular graph. I'll go ahead and write it up here. Vertex, just by looking at it now that it is in vertex form here, is I know my x value will be -1, the opposite, and that is my horizontal shift. So my graph will shift to the left one, my parabola. And we know the y value for my vertex will be +3. So my graph will shift up 3. So I'll go -1, up 3, and I'll go ahead and make a dot for my vertex. And I know my parabola is going to open upward. And we're going to go ahead and use a calculator here and make sure I have some nice clean points, because it does have a vertical stretch by 4, so it's going to be a real skinny graph. And here is the function typed into y equals. I'll go ahead and hit graph. It's going to look like this. And I'll go ahead and use the table here and find some nice clean points. And I notice that this is definitely the bottom of that parabola, or u, looking at my y values. And I really only have 2 more points I can fit on here. I could go 0, 7. So I'll go ahead and make a dot at 0, 7. And right here at negative 2, 7. I also know that the vertex, that the y-intercept is at 7 just by looking at the original standard form. So I could apply to those points without the calculator. So let's go ahead and get rid of the calculator. Let's go ahead and draw our nice smooth curve through the graph. And there's our graph. Okay, domain and range. Again, looking at my calculator, I'm going to bring it back up. If I were to scroll through this table, I could scroll forever in the negative direction. You'll notice my y values are very large. I could scroll forever in the positive direction for my x values. Again, my y values get very large, but there's nothing that's permitting me from plugging in an x value. So that means my x value is all real numbers, but I'm going to go ahead and write that in function notation, or excuse me, interval notation. And I get this. Now my range is a little bit different. When I'm thinking of possible y values, and I look over here in my y value column, I notice the smallest number I get is 3. And looking at my graph, I notice that I will never have a y value less than 3 for whatever x values I have. This is the lowest point of the graph. And so that kind of answers two questions here. It answers my range. So my range is going to be close bracket 3 to positive infinity. And then this is also bounded below. Bounded below. Let me move my calculator over. Okay, continuity. Is there any place where my hand has to come off the graph? I'm going to go ahead and move this. I don't need my calculator anymore. So if I were to use a highlighter here, is there any place where my finger has to come off this graph? And the answer is no. So this is a continuous graph. So I would say continuous. All right, increasing and decreasing. There's actually two parts to this. It is increasing for a portion and it is decreasing for a portion. I'm going to go ahead and move some of this stuff down and give myself a little room. Okay, in this particular one, I'm actually not going to move it, I guess. I am going to write the value of this vertex here, and it's negative 1, 3. And you'll notice that is the very bottom point of my graph. So if I were to retrace this, I notice my graph is decreasing, 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 decreasing right here. And then it will pick back up at this point and increase, 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 increase. So I do have a minimum, and I'll write that down here in my extrema. There is a minimum at the coordinate negative 1, 3. And then for increasing, decreasing, there are two parts. Okay? Let's start off with decreasing, since that's what my graph's doing. So we'll do that in blue. So decreasing from negative infinity, and then you'll remember that I don't care about my y values when I'm doing increasing and decreasing. So it's decreasing from negative infinity to negative 1. Okay? And then it's increasing from negative 1 close bracket to positive infinity. Right there. Okay, my symmetry. It is symmetric, but it's not symmetric about the y-axis. So this would be a none either. If it was centered over the y-axis, it would be called even. And then my horizontal and vertical asymptotes. You'll notice I don't see any place where my math is brushing up against a specific number. So both of these would be none and none.